Let me show you how to make the graph for the nuclear decay simulation. Okay, so what you want to do is you want to go to the lab, and now if you go to the decay lab, at the bottom I've uploaded a bunch of files. Okay, and these are the files that you would have created if you'd been in the class. So just pick, I don't know, one of these at random, okay, and download it, and it'll go to your device. If you're on your Chromebook, it'll go to your drive probably, right? And then go to a Google Sheet and say that you want to import something. And then you got to find that, right? So you're going to upload something, or I don't know what it's going to look like. It'll be from your drive, actually. On this one, it's on my computer, so I'm going to go into downloads and find that. Uh-oh. It's not very helpful here. I think I got to scroll all the way to test. Oh, what's there? Test, oh, there it is. All right, let's do that guy. My PC was more helpful. Then I think I just clicked import data, if in doubt. There it is. So notice that my lambda is, and you can just move these to the side there. Otherwise, it'll use that comically as the title of your graph, right? The lambda, this is the decay probability, right? Is 0.0095, right? But this really is time in seconds. Whoops, not Tim. Time in seconds, right? And those are much better titles, right? You know, it's like, ooh, wow, what did it just do? Why did it do that? All right. And then what we want to do is we want to make a graph of this, right? So we're scrolling. Ooh, that's a lot of scrolling. I bet there's a faster way to do that. You can chime in and comment and tell me how to do that. Anyway, so I'm going to go in here and I'm going to insert a chart. See if it does the right kind of chart. Ooh, it did. That's nice. And then let's go ahead and make this its own sheet. And we're going to, what we want to do, the directions are that we want to draw some vertical lines. We want to draw them where this crosses 880, 440, 220. You could even do it at 110, okay? Let me show you how to do that. We're going to edit the chart here, customize. Let's go to grid lines. Okay, and for the vertical axis, we want to do, actually, let's see, grid lines, no. Vertical axis here, let's make the minimum value be 0, and this be 1760, because of course that's what it was, right? So now it goes all the way to the top, right? Okay, then go down to grid lines, and I think what we can do is we can tell it to do 9 grid lines. Watch. Ooh, isn't that clever? If you do 9, that means that there's 8 divisions. 1, 2, 3, 4, 5, 6, 7, 8. I figured this out, right? So now we already have a line at 880. The only trick is how do you then draw a vertical line? I couldn't figure out how to draw or anything on this. So what you can do is you can copy the chart and paste it into a presentation. So I'm going to do a Command V, and then I just want it unlinked. Okay, there it is. And now I can draw lines on this thing, right? A vertical line. Is that a vertical line? What if I hold the Shift key? Does that constrain it? I don't know. I'll try it again on this next one. I'll let you know if that whole Shift key thing works. Okay, so there's a vertical line at 880. Let's find 440. Well, that's not really doing it. Okay, so let's go here and 440. Vertical line. Notice that this is, what about a little more than 60 or 70 seconds? This is like twice that. This is 2 half-lives, right? So these should be evenly spaced. That guy. Let's see, can I, does it do, it doesn't do the same thing. A nudge is a lot. Okay, and then And then we can go to 220, find where that intersects. And these are all fairly evenly spaced. You see that? These are half-lives. First half-life, second half-life, third half-life. Okay? Now the question is, how do you get this into your Google Doc? That I don't know. Let's see if we can do all this. This is the part where I don't know. I'm going to select that, and then copy, and then paste. And the lines didn't come through. Okay, so if you don't have a device where it'll do a screenshot, I think you're just going to have to do your lab in Google Sheets. Okay, you're going to turn it in a Google Sheet, and that's just fine. Add a text box, answer your questions there. If you can screenshot this, right, as I can, I'm on my Mac here, and they haven't disabled my screenshot. I'm good here. And that, by the way, is a Shift Control Command 4. Does that, right? And then you can just paste that. You can paste that, and it's got the lines on there. Okay. The other option you could do, boy, these lines aren't very vertical. The other option you could do if you wanted to is you could just print it and then draw. Oh, look at that. What just happened there? I don't know. Hopefully that doesn't happen to you. Okay, so let me answer the questions that you've got. Right. So go into your data, scroll down, and write down the time that it reaches the 3 half-lives. So let's go into here. Okay. And you got to go into your data. You got to look at your data, right? Let's find where it's at 880. Where's 880? Ooh, wow, this doesn't usually happen. Usually you have to interpolate, right? It actually hit 880 at 71 seconds. Okay, so that's our first half-life. You don't need to print this out. I'm just typing it in here because, you know, there I am, right? Okay, and then let's find the next one, which is going to be 440. Let's see, 440, does that even happen in here? This is pretty close. Oh, look at that. That's weird. 441, 441, right? So here's our second half-life. Approximately, right? You could interpolate. That's weird. Like nothing decayed. All right. And then let's find 220. Hello? All right. 220. Where's 220? Haha, it's right there. Okay, this is our third. All right, and then let's find, and that, notice that is, wow, why does it do that? Why does it, what programmer thought that was a good thing to do? All right, and then our fourth half-life is here, around here, right? So you'd have to interpolate, right? Just sort of, you know, okay. Third, fourth. Okay, so take a look at these half-lives. What we need to do is a little subtracting here. The first half-life happened at 71 seconds, right? Okay, right there, that's our time. Okay, the second half-life happened, you're going to write these down. Second half-life happened how much later? Well, about 70 seconds later. So the first one was 71, the second one was 70, right? 141. Okay, let's find our third half-life. Third half-life happened here. Well, let's see, what is 212 minus 141? A third half-life was 71 seconds as well, so this is pretty consistent for this guy, right? Okay, and then the fourth half-life is happening at 282, right? So 282 minus 212 is again 70, right? So really they're just bubbling around 70, 71, okay? So that is how you answer number 4. So write down exactly where they are. Find the time elapsed. Okay, and I even went one more than you have to, right? So, and then when you answer the questions, be sure you cite what the data is. The first half-life was 70, the next was 71, the next was 70, the other was 71. They're pretty close, right? Specifically, how does the curve suggest an exponential function? We'll take a look at it, right? Exponential functions, there's lots of things. You could talk about the half-lives being roughly the same. You can talk about whether a curve actually fits, right? You can go in and put a trend line if you want. Okay, and you have to display the equation. You're going to do that in here, customize, and then it's series. It's under series, trend line, and then choose the correct trend line there, and then label it. Use the equation to label the trend line. Okay, that's extra credit though. That's like advanced, right? So B, specifically, how does a curve suggest an exponential function? Give concrete evidence that it's exponential. That it's evidence that it's evidential. And then how does the half-life you measure compare to the half-life you would calculate using from the decay probability you used? Well, what is our decay probability? It is 0.0095, right? So how do you find the, how do you calculate the decay probability? That's going to equal what? ln 2 divided by 0.0095. Okay, so calculate that. Calculate the half-life from that. Okay, there you go. So you can turn this in as a Google Doc. If you have a printer, I suppose you could print stuff out and draw on it like we did in the day, and take a picture of it and turn it in. But I do think I should stop recording.